Hello, my name is Jerome Chang, and this is the last video report of EEE 488 for Senior Capstone Team RF CFD 39. As you may recall, we are developing an RF interrogator for detecting changes in the frequency response of radiation sensors. Since our last video, we have made significant headway in developing the envelope detector and have begun the process of researching the voltage gain controller that feeds into that detector. We have also begun research into data acquisition algorithms. You'll hear the highlights of each of these topics, starting with Peter, who will discuss the advances with the envelope detector design.
Hi, my name is Peter, and I'll be outlining some of the progress we made on the design of the analog and digital aspects of the receiver interrogator system. So for the past semester, we have been mostly in the design and simulation phase, with us iteratively optimizing and tuning the envelope detection circuit in Keysight ADS software using various distributed filter topologies with microstrip open stubs and radial stubs. To ensure minimum ripple and distortion of the received signal, the design was evaluated using transient, S-parameter, harmonic balance, and envelope simulations. Currently, the results have been fairly successful, but further examination and simulations will be required before considering the design finalized. On the data acquisition side, we have made progress on the experimenting with various real-time filtering and peak detection algorithms in software like MATLAB, but further evaluation is necessary before moving on to a practical and physical demo. Progress has also been made on the sourcing various commercial off-the-shelf components to be used in our overall system, but some additional designs may be necessary, including a custom bandpass distributed microstrip filter and an automatic variable gain control circuit, which Zach will cover next.
Hi, my name is Zach, and I will be explaining the variable gain control, VGA for short, within our system and advances within the VGA for our envelope detector. We realized early on that variable gain control was a necessity for our envelope detector. The Schottky diode within the envelope detector will need to work within a specific operating mode and a consistent power input. Our VGA module is based on a variable gain amplifier driven by a receiver circuit. Fortunately, our envelope detector, and most importantly, the Schottky diode, is virtually unimpacted by the output of the VGA amplifier. However, we will have to simulate our method of driving the VGA amplifier using our envelope detector output to create a negative 2-volt DC signal. A Wilkinson power divider will divide the AC signal from the receiver into a rectifier circuit with output of the circuit connected to our variable gain amplifier. I will now pass it off to Thane, who will discuss future tasks.
Hi, my name is Thane, and I'll be explaining the remaining tasks for our project. Right now, as we are in the final stages of the design and simulation phase, we will continue to perform simulations in Keysight ADS, source components, and implement DSP algorithms. We'll finish up this phase early next semester, after which we will move into the RF board layout and assembly phase. At that point, we will perform RF layout simulations, determine the physical design layout, purchase parts, and assemble parts on board. We expect the layout and assembly phase to be completed by the middle of the spring semester, after which we'll move on to the verification testing phase. For this final phase of our design process, we plan to verify the operation of our prototype by performing tests on it in an RF lab environment. Following any possible design iterations, we expect testing to be finished and to have a functional and cost-effective prototype of the handheld RF interrogators receiver completed by May 2021.